name is Julia McCavitt, and my action research was over the effects of inquiry-based learning on student retention. My advisor for this research was Dr. Matthew Lavery. The overall research question I was trying to answer was, does inquiry-based learning affect student retention? So the students in this research were in 2 7th grade math classes. They were in a normal math class, it wasn't gifted, and they were not being tracked. And then there were 35 students total in my research. So 17 were in the first class and 18 were in the second class. And then students were used to a lecture and traditional classroom, so none of them had really had an experience with an inquiry-based classroom. For collecting my data, I mainly did a quantitative study. So one class was initially taught about two-step equations in a traditional way, meaning that I gave them notes and they copied down what I was saying through lecture. And then the other class, my second block, was taught using inquiry-based learning. So we focused on them discovering how to solve two-step equations, us having discussions, and them having discussions with cooperative learning structures. And then they also used algebra tiles, which are manipulatives, to see what is happening when they solve two-step equations. So after I taught them this way, the students were given the same assessment. This was their initial assessment, and students in both classes were given the same one, and I collected that data and saw how the classes differed or how they were the same. And then 2.5 months later, students were tested again over the same type of knowledge, just different questions about solving two-step equations, and this was their post-assessment. I also gave my students in my inquiry-based learning a post-teaching survey, which just kind of asked them their opinions about inquiry-based learning, which since they had never gone through this, it didn't really play a role in my overall methods of data collection, but it kind of came into play whenever I made my conclusions. So for my inquiry-based classroom, which was again my second block of students, they were being taught how to solve two-step equations, and these students had algebra tiles, and we talked about how to manipulate them in order to discover how to solve two-step equations and how to do that writing out the mathematical steps without the algebra tiles once they understood what we were doing. So my results. So here is a big spreadsheet over what happened on their initial assessment. So on the left-hand side is my block 1, which was my traditional classroom, my lecture classroom, and block 2 was my inquiry classroom, my classroom that used manipulatives. So block 1, you can see down here in this corner, it tells us our overall average out of all my students was 88%. And block 2, you can see is the same number, overall 88% average. I have it broken down by student, how many points they earned on the question, their overall score, but the main thing I focused on was the overall average. So whenever I noticed that both classes scored an average of 88%, that showed me that students had the same initial level of understanding of two-step equations, which would then help me whenever I did my post-assessment. So here's a similar looking spreadsheet, but now this is the results of the post-assessment. So it's 6 questions, and it's also broken down by student and their overall percent. So now you can see the average percent here, which is 48.13% for my traditional classroom, and over here, which is 63.03% for my inquiry classroom. So initially looking at this, you can see that they both decreased in their average, but I noticed that the inquiry classroom decreased less. So initially, I said to myself, the inquiry-based classroom retained the information more than the traditional classroom, even though they both decreased. But not exactly. So after seeing that initial noticing between the differences in averages, I ran some statistics tests. I specifically ran a t-test on the post results for both classes. So it's written out statistically here, but you see the t-test resulted in a p-value of 234 thousandths. And this is not a significant p-value. It's above our range of our significant p-values. So it tells me that there's not a significant difference between the post-test results and of block 1 versus block 2. So because of that, I came to the conclusion that even though the second block retained the information more initially looking at it, when you take a deeper dive into the statistics behind the numbers, there is not actually a significant difference between the two. So even though that those numbers aren't statistically significant, I looked at other things I saw happening in the classroom to kind of make implications in teaching and what I should do next. So I talked about giving a post-teaching survey to my students. So one of the students responded and said they liked algebra tiles because it got them more focused. Another student said, I liked when you put us in groups to work together and we could teach each other and learn from each other. And the last student said, I like that you don't just tell us the answer. I like that we had to think about what we were doing. So after reading those, I noticed that students were liking what I was doing. They were seeing connections and they liked the manipulatives. They liked learning from one another. And so then I made the conclusion that in my teaching, I want to continue to use and implement methods of inquiry-based learning. I want to continue to use and experiment with different manipulatives in the math classroom, and I want to continue integrating cooperative learning structures in the math classroom, because although the numbers didn't show it statistically, I saw the differences in the students' behaviors. And then with my limitations to my experiment kind of go hand in hand. These students were unfamiliar with inquiry-based learning, so I think I might have gotten better results, statistically significant results, had I had a classroom that was used to inquiry-based learning and had experience with it. And then I couldn't flip the experiment, so ideally I wanted to take the first block that was taught traditionally and teach them a different unit inquiry-based and teach the other block traditional and see if I got similar results or if they changed. And then my sample size. I only had 35 students I was dealing with, and had that sample size been bigger, it's possible that the t-test would have resulted in a p-value that was statistically significant. So overall, even though my test didn't show a statistically significant result in student retention because of inquiry-based learning, I still believe, and research still shows, that inquiry-based learning will help students in the long run. Thank you.